Hey everybody, this is Mr. Ainsworth, and we're going to get into a similarity review worksheet here to get us set up for the next lesson here. So let's get a couple things ready here. Let's get your scientific calculator out in case you need it. That might come in handy. I'll do things by hand, but I'll also use this to make things easier. All right, and we're going to get into, like I said, a few problems here, just illustrating how easy it is to work for similar figures because it's going to be involved in our next section here. All right, so what we know is that similar shapes have proportional measurements of corresponding sides. What does that mean? Well, let's go over it. Let's read the problem first, though. All right, here we go. Find the measurements of a similar rectangle. Again, that's important. A similar rectangle that is 3.5 times larger. That's obviously important. That's called the scale factor. Okay, hopefully you remember in geometry. If something is 3.5 times larger, well, then it's 3.5 times larger in all dimensions. Okay, and I'm talking about the length and width. Okay, so we have it's 3.5 times larger than the rectangle that has a width of 6 and a length of 12.5 inches. Okay, so 6 by 12.5. So the width is 6 inches. The length is 12.5 inches. All right, the scale factor, we're going to call that K. That's usually what it's called. Scale factor K is 3.5. That means we've got to take both the width and the length and multiply them both by 3.5, and we're going to get a new width and a new length that is 3.5 times as big. So my new width, we call it W prime, is going to be equal to 6 times 3.5. All right. And what is that? And that's 18 plus 3. That's 21. If you can't do that in your head, no big deal. Go 6 times 3.5. All right, and you'll still get 21. All right, so 21 inches long. So we'll call that W prime, the new rectangle that's obviously 3.5 times as big. Times as big, right? Okay, and L prime is 12.5. All right, times the scale factor because we're growing here. This thing's enlarging. So let's do that. This one's a little bit more difficult to do in your head. So let's kick in the calculator. 12.5 times 3.5, and you get 43.75. So 43.75 inches in length. This is the new rectangle that's, like I said, 3.5 times as big. All right, well, let's play with this here. Sometimes it's not a decimal. Sometimes, oh my God, it's a fraction. So let's check it out. We got a triangle whose size is 8, 13, and 17. So we got three sides of a triangle. Okay. If the similar triangle, okay, similar triangle is 2/5 the size. So the scale factor, SF for scale factor, equals 2/5. All right. It's going to shrink, okay, because 2/5 is less than 1. Less than 1. All right. So it's going to shrink. Why? Because, well, it's 2/5 as big. And if the scale factor was bigger than 1, then it grows, which means it increases in size. If the scale factor is less than 1, then it decreases in size. Okay, so what are the new triangle's measurements? Well, let's take a look at it. Okay, well, let's take side 1. All right, it's 8. Let's multiply it by 2/5. All right, that's 16/5. All right, 8 times 2 is 16. That's 3 and 1/5. Now, or you can write it as decimal is 3.2. We'll call it meters. Okay, like I said, 16 divided by 5. Okay, it's 3.2 or 3 and 1/5. You're going to do that for all sides, right? So you take side number 2, all right, which is 13. So 13 times 2/5, that's 26/5, and that's 5 and 1/5. All right, that's 5.2 as a decimal. Side 3, okay, it's 17. So 17 times 2/5. All right, 17 times 2 is 34. Divided by 5, that's 6 and 4/5. As a decimal, that's 6.8. Okay, you can check that, by the way. You can take 34 divided by 8, and you get, oh, not divided by 8, 34 divided by 5. Got to press the right buttons. All right, and you get 6.8. Okay, so these are the new measurements. All right, the new measurements. What are the measurements of the triangle? Well, they're 3.2, 5.2, and 6.8. They shrunk, they got smaller because, okay, the scale factor is less than 1. All right, so the new triangle is smaller. The new triangle is smaller, all right, because scale factor is 2/5, which is less than 1. That's a little note there. Okay, next one, we got a rectangle R, 16 by 23. Suppose R prime is known to be similar to R. If R is 2.5 times larger than R prime, then what is the length and width of R prime? Okay, so it's 2.5 times larger. Okay, so the original rectangle is 16 by 23. R prime, uh, okay, and this original rectangle is 2.5 times larger than R prime, which means R prime is smaller. That's what it tells me already. So R prime is smaller. All right, because of that, you got to divide by the scale factor of 2.5. Okay, so let's do that. We got length here, length 16, width 20, excuse me, reverse that. Okay, width 16, length 23. All right, so we're going to divide by the scale factor because we're getting smaller. All right, so we got to take, for the width, okay, I got to take 16 divided by 2.5 because we're getting smaller, right? And like I said, if you can't do it in your head, no big deal, right? Use your calculator. All right, so divide by the scale factor and you get 6.4. All right, you get 6.4, and that's going to be the width of R prime. And then the length, well, what is that? Well, it's 23 divided by 2.5. That's 23 right here. So you take 23 divided by 2.5, and it should shrink, right? 9.2. Okay, so 9.2. So the new rectangle, all right, smaller. All right, what is it? Well, it's 6.4 by 9.2. Why? Because it shrank. The original one is 2.5 times bigger than the smaller one, or the similar one. So the similar one's got to be smaller. So it's 16 by 9.2, whatever the units are. Okay? Okay. Okay, assume that in each part the shapes are similar. Make sure of that. That means that ratios of corresponding sides are proportional. Ratios of corresponding sides are proportional. All right, that means equal. Okay, so that's a very key aspect of similarity. So you got to remember that. I actually talked about that before, but it's going to be involved in all of these. All right, so let's see what we got going on. So what do we have here? In the first one, we got two isosceles triangles here. They're isosceles. That means we have two congruent sides. All right, that one's congruent to that one. That one's congruent to that one. What should the measurement of the base be of the bigger one? Okay, so let's take a ratio. All right, we're going to take the left side to left side ratio. That's 8 to 30, and that's going to be proportional to base to base. All right, base to base, or 5 to x. We're going to cross multiply. Okay, that means we got 8x is equal to 150. Divide by 8. And what is that? Well, we take 150, all right, and divide it by 8. Ooh, what do we get? 18.75. Okay, so it's 18.75. Okay, on this one here, we're going to take the length to length, all right? So 21 to 49, and then we're going to make that proportional to width to width. So x to 35, small to big, small to big. Okay, and so what do we have? We cross multiply, you get 49x is equal to 29 times 35. Excuse me, yeah, 21 times 35. So you work that out, you get 735. So 49x is equal to 735 divided by 49. And x is equal to whatever you get, right? So what is that? Let's figure that out. 735. So 735 divided by 49. We get 15. Okay, how about that? 15. So this side right here is 15 units long. 21 by 15 is equivalent to 49 by 35. It's similar, okay? They're similar. They have the same shape, so they have the same ratios. Similar, same shape. So similar. All right, same shape. All right. Moving on. Okay, so same thing here. Similar, same shape. So what is x? So I don't know. Well, I do know. So why is that there? That shouldn't be there. Okay, pretend you didn't see that. Oh my goodness. Okay. All right, pretend you didn't see that. Okay, we got to find x and y. So what we're going to do is we're going to relate left side to left side. So 10 to 4. So 10 to 4. And that's going to be equal to, all right, right side. No, 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 no. Right side, no, no, no. Okay, right there, 11. So x to 11. Cross and multiply, you get 4x equals 110 divided by 4. All right, and x is equal to 110 divided by 4. 110 divided by 4, and you get 27.5. 27.5. So 27.5. Now, next one, pretend you didn't see that. We're going to use the same ratio, 10 to 4. So 10 to 4 is also proportional to the base, this base to this base here, y. Okay, don't ask me why, just it is. Okay, so you get 35 to y. So in this case, you get 10y is equal to 4 times 35. It gives you 10y is equal to 120 plus 20, 140 divided by 10. You get y equals 10. All right. Oh, excuse me, not 10, 14. So 140 divided by 10 is 14. Sorry, guys. But we knew that. But pretend we didn't see that. Okay. I forgot to cross out the answers. Okay, on this one here, on the D, all right, again, think simple. Length to length. Oh my God, the scale factor is 2. You could use that if you want. However, you can also do it in proportions. All right, width to width. So I'm going to do it by proportions, even though you can just double that to get that. All right, so anyways, what am I saying? 17 to 34 is equivalent to x plus 5 to 25. Okay, that means 34 times x plus 5 is equal to 17 times 25. That means the 34x plus 150 and 20 and 170 is equal to 140 and 35, 175. All right, subtract 170, subtract 170, you get 34x is equal to, could this be right? Okay, 5 here. What's wrong here? What am I doing? Hang on. 17, hang on. X is, what am I doing here? 145. So let me check. 17 to 34, x plus 5 to 25. That looks good. That's correct. So I wrote down 7. That's the problem. Okay, I knew something was wrong because I wasn't getting the right answers here. It wasn't making sense. Okay, I got to write down the right number. 17 times 25. Okay, here we go. So 17 times 25. That's 17 quarters or 425. So 425. So subtract 170. And you get 34x is equal to 425 minus 170. And you get 255. So 255 and then divided by 34. Oh my God. This is going to end up gnarly here. Okay, so 34 here. So divided by 34, what do we get? You get 7.5. So x equals 7.5. Believe it or not, that's it, guys. Okay, sometimes it happens like that. Okay, next one, we got to find x and y here. So let's work it out. Ooh, x, y, and v. We got 3 things to figure out. Well, the first thing I know is that 27 is corresponds to 9. So I know that 9 corresponds to 27. So the bigger figure is 3 times as large. So the scale factor is equal to 3. So I can just, triple these. I can triple that. So this length here, well, that's 75. I triple this, times 3, I get 54. And then, ooh, I divide by 3, I go the other way. Ooh, watch this, divide by 3. I get 10, so I already know that V is 10. You could do it that way. That's the easy way to do it using the scale factor. All right, but I'm not done yet. 54 equals y plus 7. So y plus 7 equals 54. So y must be equal to 47. I know that 75 equals x minus 12. So x must be equal to 87. I also know, let me see. Oh, I know that v is equal to 10. I already figured that out. So you can use the scale factor. Use the scale factor, all right, to figure this out. On this triangle problem here, what do I know? I know that, uh, okay, so right side to right side. So 42 corresponds to the 147. So I can use that ratio. So 42 to 147 is proportional to left side, right? This to this. So 2x plus 3 to 129.5. So you want to cross multiply and see what happens. So you do that and you get 147 times 2x plus 3 is equal to 42 times 129.5, whatever that is. So let's figure that out. So 42 times 129.5, and I get 5,439. So 5,439 multiplied twice here, so you get 147 times 2. Well, that's 294, so 294x plus 147 times 3. All right, you get 441. Subtract 441. So you get 294 times x is equal to this. So let's clear this out. 5439 minus. Okay, you get 4998. 4998. Divide by 294. Divide by 294. Let's see what happens here. All right, so divide by 294. Oh my God, you get 17. How about that? Okay, so you get 17 there. And then you work it out. You do the same thing. 42 to 147 is proportional to base. All right, so 18 to 5y minus 2, and y is equal to, when you work it out, you get y equals 17. And, let me see the other one. No. You get 2x plus 3 to 129, so, oops. So 2x plus 3 to 129.5 is equal to 42 to 147. So you set this up and you work through this, you get x is equal to 17 when you're done, believe it or not. No, wait a minute. I already solved for x. What am I doing? X, y, oh, and that's it. Okay, well, you could have used that, but you don't need to. Okay, so there you go. So you got your y and you got your x, you're good to go. You're happy. Because, hey, man, you got them right. All right, this is Mr. Ainsworth. We'll see you in your next lesson on gnomons, okay, using all these similarity stuff. Okay, I'll see you then. Bye-bye.